Hi, this is Dr. Prakash, Assistant Professor, Associate Dean Swimming Welfare Department of Civil Engineering, SR University, Varangal. So continuing with our topic, today we are going to see field and office work. So how we are going to compare your field work with the office work. So what is the field work? So field work is an activity that is carried out in the field. So in surveying, it has lots of activity that has to be carried out in the field, so including activity of recording data, measurement, and all the data what you are doing on the field. On the field is called as a field work. So measuring, marking, everything will come under field work. Okay. So the instrument used in the field work are chain for measuring your distance, compass for measuring your included angles, including your bearing and other things. Line table if you are using plotting and measuring in the same time, it is you are going to use flying table. So clearly to measure your distance, I mean to measure your horizontal and vertical angle precisely with respect to a minimum of minutes and seconds. So you can use theodolite. Potentiation we are going to use for all the aspects what we have done, including a chain. So the potential consists of chain, compass, and theodolite. Everything is combined. It is do in a single instrument. Then GPS to locate your location with respect towards your lateral longitude. Then leveling staff to measure your height. Right? So the key activity which has to be done in the field or thought or setting up of your instrument. So that is your hardest task because initially your instrument should be set up as per the procedure. If the setup is not done properly, obviously it will be a cumulative error. Cumulative error is nothing but initial setting up of instrument is wrong. Obviously, the measurement what you have took from the instrument will also be wrong, right? So then after setting up of instrument, you have to measure the angle, distance, and elevation, whatever required, what is the work assigned to you. So you have to do that work accordingly. Then after measuring the angles, distance, and elevation, so it has to be recorded in the field note. So according to your feasibility, you have to record your measurements, angle, seasonal distance on your field note. Then making reference point and control stations. So this is very much important because if you're dealing with a huge, very large area, so you cannot complete your survey in a single day. In that condition, you have to mark the reference point and control station well in advance. So while where you have started your work, where you are going to complete your work, so that has to be marked very precisely because, as I said, if you are dealing with a very large area, so huge, it cannot be completed in a single day. So at the end of the day, where you have completed your survey point should be properly and precisely marked to continue your work on the next day. So that is the most important thing you should consider on your surveying. Then performance of recognition sketching, right? So recognition nothing but after taking measurement, you have to check the accuracy of your work. And sketching, you have to do rough sketching on your for your measurement or diagram or your length what you have to on the day for your particular plot. So then after your field work is completed, then we are going to deal with office work. So office work is a post-field activity that has to be carried in office. So, for example, if you are collecting data, if you are doing leveling, right, you are collecting a lot of data with respect towards your survey point. So then that raw data should be converted to a data which is understandable. Okay. So raw data is not usable. So converting the raw data into a usable form is done in an office. So that is a process and analysis the data that is collected on the field. So that field work, what you have collected should be verified on the, should be rectified and should be verified on the office work. Okay. So a lot of softwares are available to use to do these office work. So starting for your sketching, you can use your AutoCAD. Civil, if you're dealing with 3D, you can use the Civil 3D. This software for your mapping and GPS locations, Excel sheets to calculate your quantity by with your formula, cutting, fitting, filling quantity, everything can be calculated. And there are specific survey software for each and everything, like the ArcGIS or you are dealing with any of the data. So accordingly, it has a specific survey software for specific purpose. So the key activity what we are going to perform in this is checking and correcting the field note. So you have to check. So for example, if you are doing leveling, so you have to check your backside and foresight whether it is properly done. what is your intermediate state, what is the height difference, everything should be calculated. If you're doing a closed traverse, whether your included angle, of sum of included angle or as per the requirement or not, so those things you have to check accordingly for your needs. Then calculating the coordinates, distance, and elevation, right? So with your raw data, you're going to calculate the coordinate, what are the coordinate which is for there, and what are the thing you have to find. Then distance, for example, let's keep that you are doing a survey on tachometer. So your distance should be calculated, right? So you have to calculate the distance with your required formulas. Then elevations. So as I said, with your RLR benchmark, you have to calculate the height RL of height difference of a particular point or survey stations. So that is called as calculation of elevations. Then with the data, you are going to plot a map, right? If you took a data for a map, the plotting of map should be done. And if you are taking a data for drawing, for example, AutoCAD 2D, 3D drawing or any other plot drawing, everything you have calculated, then you have to prepare a drawing for your uh, raw data. Okay. Then you are applying error adjustment. So this is more commonly used on your compass and your chain surveying like your traversing. So there will be a percentage allowable error. Okay. So if there's a error, so what is the percentage of error? How we are going to rectify the particular error? That has to be done. So that error calculation adjustment should be done in the officer because we don't know whether that is error data or actual data in the field. So once we are doing these corrections and calculations, then we'll come to know that's error and how we are going to adjust this error. So that is applying error adjustment. Then after doing everything, you are going to submit a report for your client and document it. So that is preparing survey report and documentation. So that's the work assigned to you. So that work you have to complete. So these are the key activities which has to be carried out in the office work. So relationship between your field work and officer. How you are going to relate your field work and officer. As I said, your field work will provide a raw data, so which is not process data. Just you are taking measurement and filling the measurement on your data sheets. Okay. Then office work is a process it into usable data. So that raw data, that is a data which is understandable only by you because we have taken a measurement, right? So now converting that raw data into usable output, which can be understandable, which can be used for the client. So that process is called as office work. Then error in a field work affect office work calculation and vice versa. As I said, the error which is occurring on the field work, it will completely reflect on your office work calculations. Because if you're doing entire surveying on a plot, so the initially you have started with some work, so there is a error. So you are not recognizing that error. Once everything is completed, at the end of day, you are going to the office and calculating the thing, right? So the error in field work, it will completely affect your office work, right? Because the data what you have collected is error. Obviously, the calculation what you are doing from the collected data with the error data will give an error calculation. It's an error output. So right, so this is and vice versa. If you're doing error on your office calculation, then that will reflect on your field work also. If you are doing your area calculation wrongly on your office work and you are replicating that plan or a boundary area on the field, so that also will affect the work in the field. So it is a vice versa. So both the things should be error free. So as a surveying engineer, as a civil engineer, you should be cautious on these things. Then if your office work and field work are in good coordinates, right? So what is the output you are going to get, right? So the first one, accurate maps and plans. Okay. So you'll get an accurate map and plans because the data what you have collected and data what you have processed is accurate for your requirement. So when representing your measured data and the office and the calculated data on a map, it will gives you exact map which of a location or exact plan what is required for the execution. So those things, this can be achieved only with a good coordinate with your field work and the office work. Then efficient project execution. As I said, in civil engineering, planning of project is very important because a delay in a day can cost more to the company, right? So efficient project execution should be done. So you have collected some data, you should calculate what are the data required for your cutting and filling. So every calculation should be done very well in advance. So right. So this efficient project execution is needed it will be done by your effective coordination between your field work and the office work. Then reduction in rework and cost. So as I said, we are dealing as a civil engineer, we are dealing with execution work. A huge execution or a rework in your site will cost huge. Okay, so it will cost more time and it will cost to the company. Okay, so those things should be removed uh, if you are good, having a good foundation between your field work and the office work. Okay, so the reduction in the rework and the cost will be done only if there is a exact correlation or correlation between the person who is working in a field or a person who is working in an office or the work what you have done in a field with what is activity in office should be in a good coordination, right? With a minimal error. So this will be carried out only when you are having a exact coordination between the field work and the office work. So next topic we are going to do a plan, map, scale, and transfer scale, right? So plan. What is a plan? Right? A plan, it is a graphical representation of some scale. For example, if you're dealing with your plan in feet and inches, you should give your scale in feet, or if it is meter, you should give in a meter. So it gives a features or near below surface of earth, which is projected on horizontal plane, right? So it is the proposed, you can see here, it is a proposed work, what we are going to do. So these are the boundaries of this plot 1 and 2. So how we are going to construct our, so that is called as a plan. Then horizontal plane is represented by a plane of drawing sheet. So this is a horizontal plane, it is represented by a plane of drawing sheet where your plan has to be drawn at required scale. Some scale is not depend upon your scale what you are using for construction. So that is called as scale, right? However, the surface of Earth is curved. It cannot be truly represented on a plan without deterioration. So when you are dealing with a huge area, for example, if your area is more than a kilometer, so if you are not considering the curvature of the Earth, there will be distortion on your plan. So that has to be considered. In a plan surveying, the areas involved are small and Earth surface may be considered as a plane, right? If you are in a plane surveying, normally you'll consider your area, Earth surface as a flat surface, right? And you're not considering the curvature. So the plan constructed on orthographic projection and plan drawn on relatively large scale, it can be considered as your with a curvature of the Earth. Okay. The next one, map. So when you're doing a scale for a graphical projection of a huge area, so a small area is called as a plan. When you're dealing with a huge area, it is called as a map. Okay, right? So the graphical representation of is called as a plan. If a scale is larger, while it is called as a map, as I said. Here you can see. So this particular building is a plan. When you're dealing with a lot of buildings out there, you can see that this is a roadway indications are there. So there is a project which is going on here. What is there is a corner hall here. There is a restaurant hall here. So these are the plans. So this map has all the data or detail of a area which is located, right? So this is called as a map. Okay, when you're dealing with a large data, large area plan, then it is called as a map. Okay, then scale. So this is very important on your surveying because what is the scale, how to convert your scale up and scale down, you should come to know. So without that, you cannot identify what it is going on. Okay. So it is a basic requirement for preparing a plan or map, as I said. So this scale is a basic requirement for preparing a plan or a map. Okay. So before that, what is a scale? So scale is a measurement. It used to represent the distance on a paper. For example, in your map, if see, so here you can see scale 1 is to 1 lakh. Okay. Here the scale is 1 is to 1 lakh. You can see when you are measuring a distance of 1 here, right? So this has to be multiplied with this 1 lakh, right? So that is a scale. So conversion of scale from your paper drawing sheet towards your ground, from your ground to drawing sheet is called as a scale, right? For example, if you are measuring 1 centimeter on a map, okay, it represents 10 meter on the ground. So that is for this the scale will be 1 centimeter is equal to 10 meters. So if that will be clearly given on your drawing sheets. So so what you have given here, so it will be clearly given. Now if you are measuring, for example, if you are measuring 1 centimeter, for example, this is your distance of 1 centimeter. You are measuring here, right? So when you are converting this 1 centimeter into the ground, So instead of 1 centimeter, what you have measured here should be converted to 10 meters. So this scale is very much important because in your drawing, all the drawing will be for the scale. Okay, right? So some changes will be there, some measurement will be omitted. So if you want to take the measurement which is marked on the plan, so if your drawing is drawn for the scale, then you can measure that distance on your map and then convert that distance into the scale and you can mark that point on your ground. So this is the major advantage of drawing your map or your plan for the scale. So types of scales in surveying. So you can see there the first one is a plane scale, next one is diagonal scale, next one is chord scale, next one is vernier scale. So what is a plane scale? So plane scale is nothing but it is used to measure only one unit, for example, meter or kilometer. So when you are measuring a distance and it is measuring only one unit, a meter or kilometer, so then that scale is called as a plane scale. Then diagonal scale, right? It measures 3 units or more. So if the scale has three or more units to measure your same distance, so that kind of scale is called a diagonal scale. Then chord scale. So when you are measuring a set of angles, when you are measuring an angle or included angle, then that scale is called as a chord scale. Then vernier scale for an higher accuracy, if you are using vernier caliper nearly to 0.1 mm, then that scale is called as a vernier scale. Okay. Now I'll see everything in a detailed way. So you can see here the diagram clearly indicates this is your plane scale. So there is only one measurement. So in top you are having millimeter and centimeter, and in bottom you are having feet and inches, but your measuring will be indicating only in meters or decimeters. So that is called as a plane scale. So this is diagonal scale. It has many measurements. You can see here there is a distance measurement here, and we can use the scale conversion point here, and this is your inclination point, which can be easily measured on your uh, ground or on your map. So this is called as diagonal scale. So next one is a chord scale. So chord scale which is used to find a distance of a chord or mark that chord into your curve. For example, so this is a point what is marked on a drawing. So you have to measure the distance from 0 to 1. So this has to be converted from this with the same diameter or a chord distance. You can mark all the lines. So to measure these lines, so this is called as a scale of chord, right? The next one is a vernier scale. Okay. So vernier scale is nothing but when you are measuring a distance for the precise of 0.02 mm. So then you are going to use a vernier rule. How to use a vernier scale? So top is a centimeter. So this is one inch. Top is centimeter scale, and bottom is a vernier scale. You have to measure a distance. So it is 3.123. So 3.3. Sorry, 123. It is 3.8. Okay. Then which line is exactly coinciding with it? So it is 3.815. So that is the distance what you are going to calculate from this. Okay. So now we are going to see what representative fractions, right? So we have already seen about the scale, how we are converting the scale into the map and map into the scale. So that fraction is called as representative fractions. So it's a numerical ratio that expresses the relationship between a map and the ground. For example, 1 is to 50,000. So one division on the scale is equal to 50,000 division on the ground. So if you are measuring 1 centimeter on the scale on the map, and it is equal to 50,000 centimeter on the ground. So that is that conversion you are using, right? So that conversion is called as representative fractions. Okay. So comparison with the representative fractions. Okay. So here, plane scale, you are having one unit which is 1 centimeter is equal to 10 meter. Okay. So diagonal scale, multiple units is more precision. 1 centimeter is equal to 1 kilometer with meters. Okay. So with reference to meters, you have to identify these things. Then chord scale. So chord scale, it is a set of angles. So which is used to measure the degree. So you are going to measure the degree with that. And vernier scale, it is very small division. When you are dealing with a small machinery object, you can deal with this. So we are going to use a vernier caliper. The reference setting is nothing but it's a ratio from no unit. So 1 is to 50 centimeter. So it has no, it doesn't have a unit. So if you are measuring 1 meter on the map and you are measuring 50,000 meters on the ground. So if you are measuring 1 millimeter on a map, so it is equal to 50,000 millimeter on the ground. Okay. So it doesn't have a unit. You can use your feasible unit for your calculations. And here the next topic is shrunk scale. So what is a shrunk scale? So there your map can be shrunken due to your physical changes. For example, your scalar map has been altered. So typically due to your physical shrinkage of a paper, because paper is a material that can shrink and expand. Okay. So this shrinkage can occur due to change in temperature. It can due to temperature it can expand or contract. Due to humidity it will expand. And aging of material also cause deterioration of your material or where the map is drawn. So this will causing a original dimension of a map to contract. Okay. So you have drawn that map for the scale, right? Okay. And that map, what you are converting, for example, you have drawn this for a scale which is 1 centimeter, right? So the scale is shrunken. So it is actually 0.9 centimeter, but you have already marked this as 1 centimeter. So this shrunk is 0.1 centimeter. So when you are measuring that on the scale, it will be 0.9. So the shrunk scale percentage is 0.1. You can see. So the original scale, what is become? Then original length divided by shrunk scale. So this is called as shrunk scale. So now we'll see an example for the shrunk scale. So a shrunk scale is typically used in geometric transportation and scaling, okay, particularly when reducing the shrinkage size of an object, okay, while maintaining the shape and propagation, the method of changing scale factors. So this is a workflow example what you are going to see in 2D scaling. So let's consider rectangle dimension. So length is equal to 8 units. It may be in centimeter or millimeter. So there is no issues on that. Or you can keep this is in meter. Okay, right? So the width is 4 units. Okay. Now let's the shrink with a rectangle scale factor of 0.5. The shrink scale factor is given as 0.5. The scale factor of 0.5 means both the length and width of rectangle is reduced to half of its original size. Okay, right? So now we have to find the length after shrinking. So new length is equal to original length into scale factor. Okay. So your new length is equal to the original length is 8 centimeter and the scale factor is 0.5. So it is equal to 4 unit. So it is equal to the distance is equal to 4 unit. Okay. Then width of a shrinkage. So this is your length and width is equal to same 4 into 0.5 is equal to 2 units. So while applying this shrunken scale factor of 0.5, the new dimension of rectangle will be length is equal to 4 unit and width is equal to 2 unit. Okay, right? So when you are converting this, so for example, this is your rectangle. So when you are converting, so this is actually 8 and this is 4. After your shrunk scale, it has become as, so this is 4 and this is 2, right? So this shrunk scale factor is given. So final verdict of a rectangle has a dimension of 4 units as a length and 2 units as a width. So this is here shrunk scale example, which is clearly shows that due to your shrinkage, your measurement also shrinks. Then we are going to check with the chain surveying and technical terms. What is the chain surveying? We'll see in a detailed way. What is the chain surveying? So chain surveying is a classical and tier 2 method of land surveying. As I said, so it is a classical method and it is very oldest method of your. It is a classical method and it is a very oldest method on your surveying. Okay. So this technique which relies a linear measurement using a chain or tape. As I said, you are going to use only, you can do only a linear measurement, either length or a width. So it is a single unit measurement. So you cannot measure other dimensions like your angle or your included the bearing, everything you cannot do. You can just measure the distance between your lines. So that is called as a chain survey, right? So when you are dealing with a well suited for small, relatively flat areas with simple features. By understanding the core principle of this measurement, so the chain surveying is a professional and land surveying can leverage this powerful tool so accurately measure the distance for your minimum flow. Okay, so this is a typical sketch of your chain. So you can see the distance from your handle towards your first link is 200 mm. So this is also 200 mm. So there is a distance, each is connected to each link. There will be a pendant for indication of your distance in meters. So it will show you one, if it is 1, it is 1 meter, if it is 5, it is 5 meter, if it is 10, it is 10 meter. So depending upon everything, it is there. So this is your bolt. This is your enclave length of a chain. This is your collar which is attached with your chain. So this is a typical diagrammatic representation of your chain. So now we are going to purpose and principles of chain survey. Okay. So first one is a measurement of distance. So as I said, a primary purpose of your chain is to measure the distance. Okay, between various points, a plot line forming a foundation accurately mapping the area. So next one, with the measured distance, you can establish the boundaries. By precisely measuring the length of a plot and perimeter and chain selling, it helps to clearly define and document the boundaries properly or land parcel. So everything you can do it clearly with the measurements. Then determining area. Once you have measured, for example, so this is your plot area, right? So you measure the breadth and you measure the length. So with the measured area, so length into breadth will give you the area. Okay, right? So determining the area with optimum chain survey can be used to calculate a total area of the plot, which provide a crucial information for land use and planning developments. Right. So this is your chain survey. The next one, types of chain. So the chain are typed into different types depending upon the distance, right? So there is a metric chain. So first one is a metric chain, second one is a Gunter chain, a survey chain, next one is an engineer chain, and last one is a steel band. Okay. So first is a metric chain. What is a metric chain? So metric chain is a chain which has a meters of 5, 10, 20, and 30 meters, which is commonly used in the countries that follows metric system. For example, if we are following meters, then we can use this chain for the measurements. Okay. So there are five meter chain, 10-meter chain, 20-meter chain, and 30-meter chain. So the commonly used chain is 20-meter chain because you can see that chain is completely made of a steel content, which is very heavy to carry. So every 30-meter chain, so the length of a chain is also will be maximum depending upon the increase in length of chain. The weight of a chain will also increase. The handling of chain is hard. So normally they will use the 20-meter chain, which is on your normal measuring. Then Gunter chain or surveying chain. So this is feet chain. So 22 odd or 4 pole chain, 66 feet. So it is primarily used in English speaking countries. So they'll use this Gunter chain for surveyors. So next one is engineer's chain. So this is commonly used in railways and roadways because they want to measure a long distance. So that is called as a engineer's chain because to measure a long distance road is you are measuring it in the road in terms of kilometers. So for every 30 meters, you have to use this underfoot chain, which is used for measuring on a large rail loop or road base. Then steel band or steel tape, it is varies commonly 30 meter to 100 feet chain. So it is very precise when compared towards your chains here. Your steel band is very precise because the measurement will be near to millimeters. You can measure the distance near to millimeters, so which is very useful for a precise measurement when you are dealing with the building surveying, right? So in your building surveying, if you are using this steel band, it is very precise to calculate the distances. So these are the pendant which indicate on your chain. So this is 16, this is 20 by 80 links, this is 30 by 70 link, depending upon the link projections on your scale, it is marked as the distance. So then terminology in chain survey. So this is very much important here in your plot. Everything, what is that one you can see. So first one is a survey station, next one is a baseline, third one is a tie line, and fourth one is a offset line. So in this diagram, we can clearly see the triangle which is marked. So these are the survey stations. So these are the edge boundaries where you have to start your surveying from the initial point and you have to end it at the same point. So this A, B, C, D are called as survey stations. So the line which is connecting your major survey station is called the baseline. You can see here. So this is also baseline. They have marked this line which is connecting from D to B is called as a baseline. Okay, so it is connecting major survey station. So that is called as a baseline, which is used to establish a primary framework for your reference of your measurement. Then tie line. The tie line is a subsidiary line. You can see here that is used to locate detailed features. Okay. For example, it is projected from your main line and it is connected towards your any survey stations or any road located near everything you can mark with this tile line. So here it is connected from main line, which means to capture additional spatial information. If, for example, if there is a lake located here, so this tile line will be projected up this distance, indicating a distance from this point, some make it as D1. From this point, D1 to D2, the distance has to be measured. There is a lake. Okay. So you can include an angle also with respect towards your angle between your D and P. Right. So this line is called as a tie line. Then offset line is a lateral, which is if this tie line is marked as rectangle triangle for your existing baseline, then that line is called as offset line. Right. You can see here, so here there is one tie line, so it is connecting between your major tie line and the boundary line. So there is a road in between this one. So to indicate that they have connected this. So when you are doing these measurements with respect towards your baseline in terms of 90 degree, so that is called as offset line. So this offset line is used to indicate any existing structure which is located on the map. Okay, right? So this is your offset line. Then advantages of chain surveying. So it is simplicity, right? So chain is simply and straightforward measurement. It will not complicate your distance in measurements. Then cost effectiveness, it compared to more advanced surveying methods. So chain surveying is most cost effective. So practical choice, small scale project, you can use this for the area and limited budget. Then it is while it is primarily suited for small flat area, chain surveying can also be adapted to survey more complex terrain through the use of techniques like indirect ranging and offsetting. So it is versatile. So it is used for versatile purposes. Means many purposes you can use this chain surveying for your measurements. So this is all about chain surveying, and thank you.